Yeah,
I agree
and
with
then conjugate.
Yeah, so tell me it. Say it to me. A
A
squared.
squared minus b squared bracket minus 2abi.
Yeah. So it's just trying to get your algebra a little bit stronger. That's why I did this. And then use polar form, calculate z squared. What's the answer for z squared if it's in polar form? Think de Moivre's theorem. What's the answer, guys?
R squared cos n theta. I mean cos 2 theta.
2 theta. Yeah, or you mean cis if you want to just go faster.
Okay.
Cis 2 theta. Julia, agree?
Yep.
Yeah, done. And then again, 1 over z1. So 1 over r cis theta. Well, you know you can't have I in the bottom. So it becomes 1 over r. Whoops. Well, r is attached to both of them, isn't it? So r I sine theta. And then you just multiply by its conjugate. Cos theta minus I sine. R cos theta minus r I sine theta. Multiply that to the top. You could have factorized the r, you didn't have to do it the way I just did it. And the bottom, you guys know it's always r squared cos squared plus r squared sine squared. And then what happens to when you factorize r squared out? You're going to have cos squared plus sine squared, which is just 1. So literally your denominator is just going to become r squared, and then that will also cancel out with one of the r's on the top. So you end up with that. Was that too fast?
No.
No? Rav? Too fast, or you're okay with that as well?
No, I got it. I got it.
Yeah. I'm not doing anything fancy. I mean, if I was doing something new, I would have slowed it down a bit, but I just, conjugate, looking for things that I can simplify. Yes, I can factorize and then cancel things out, and it just works out. Exponential form, same thing. Z squared, it was meant to just look like this. RE I theta squared. And then if you've done it right, it should end up with exactly the same modulus as this guy and the same angle. The only difference between them is this one's in EI, this one's a cis. EI, cis. All right, you just do that. But see, for reciprocals, actually, look at this. Look how ugly this one is. Right? Ugly. But now look how nice this one is. So what did we just do? We just did triple I. So we'll do triple I for this one. This is 1 over r e I theta. Right? Which is just 1 over r e to the negative I theta. Look, same answer. 1 over r, 1 over r, 1 over r. E is just your cis. And then because negative I theta, we know that means cos, if we remember this, cos is even. So cos of a negative is still positive. It doesn't matter. So cos theta or negative theta is still cos theta. But then sine negative theta becomes negative sine of positive theta. So let's write that down. Cos of negative theta is the same as cos theta, but sine of negative theta becomes negative sine theta. But you can see when you should probably go and do this one, very rarely, but this one works very nicely. So that was the idea of that little thing. And then here I just said, choose anything you want now and just do it again. Choose any numbers you like. Doesn't matter. So do you feel like you can do that then for this week?
Yeah.
Yep.